Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Proximal Policy Optimization. PPO. The stable way to train complex AI behaviors. Imagine you're trying to teach a virtual robot to walk. You give it a good job. Single quote. A reward. When it takes a step forward and oops. Single quote. A penalty. When it falls. Sounds simple, right? In the world of AI, especially with complex tasks like walking, driving, or playing games, teaching an AI to learn effectively and stably can be incredibly tricky. Sometimes, the AI tries to learn too fast, takes a wild guess, and completely forgets everything it knew, sending your development process into a spiral. We need a smarter way to guide its learning. At its core, this type of AI training is called reinforcement learning. RL. Think of it like this. You have an agent, RAI. Like the robot, it interacts with an environment, the virtual world it's in, based on its actions. Moving a leg, turning a wheel, the environment gives it a reward. Points for walking, penalty for falling. The agent's goal is to learn a policy, essentially, a set of rules or a strategy that maximizes its total rewards over time. For developers, this means designing an environment and reward system that clearly defines the desired behavior. The policy is the AI's internal decision-making system. It's like a set of instructions that tells the AI, given what I see right now, the state, what's the best action to take? Initially, this policy might be random. Through RL, the AI gradually updates its policy to make better decisions. As a developer, you're essentially building a system that allows this brain to evolve and become smarter at its task. A common issue in RL is that when you try to update the AI's policy, it's easy to overdo it. Imagine telling your robot, "Okay, that last step was good. Now try to walk way faster." If the update to its policy is too big, the robot might suddenly flail its limbs wildly, fall over, and essentially break its learning. It jumps to a new, bad policy and forgets the good things it learned. This instability makes it very hard to train complex AI behaviors reliably, often leading to endless tweaking and frustration for developers. This is where Proximal Policy Optimization, PPO, comes to the rescue. PPO is designed to prevent those wild updates. The key word here is proximal, which means close or near. PPO ensures that when the AI updates its policy, it doesn't stray too far from its previous working policy. Think of it like putting a speed limit on how much the AI can change its mind at once. For developers, PPO is a powerful tool because it makes the training process much more predictable and less prone to catastrophic failures. Without diving into deep math, PPO works by introducing a clip or a boundary. When the AI tries to update its policy, e.g., try this action more often, PPO checks if this proposed change is too drastic. If the change would make the new policy significantly different from the old one, PPO clips it back, limiting how much it can change. It's like having a guardian angel making sure your AI takes safe, controlled steps rather than risky leaps. This clipping mechanism is a core reason why PPO is so stable and widely used in real-world applications. PPO's stability is its superpower. Because it prevents policy updates from going wild, PPO allows you to train AI for incredibly complex tasks, like sophisticated robotic movements, advanced game AI, or intricate control systems, with much greater confidence. You spend less time debugging erratic AI behavior and more time building impressive, functional systems for developers. PPO is often the go-to algorithm when you need a robust, reliable foundation for your reinforcement learning projects, enabling you to build AI that truly works in the real world. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.